Among all the colonization projects, there are some that have focused on taking advantage of using the resources on asteroids. In fact, these could be considered the first real step toward an imminent future space industrial revolution.
The asteroids are the key to an affordable program of human exploration for our civilization. So the main advantages of the asteroids for human settlements is that they allow us to engineer worlds in space that provide all of the needs for human habitation.
The first aim of the colonization of the asteroids would be the mining. Asteroid mining is a proposed industrial process in which asteroids are mined for valuable materials, as rocket propellant or certain raw materials or metals that are scarce on Earth.
We concluded that the asteroids were the best place to mine for delivering material to Earth orbit.
The asteroids right now are known to be the greatest resource of mineral resources. Economically, one asteroid could produce $1 trillion worth of revenue over a short period of time, mining it and transporting it to Earth. And there are companies seriously planning to go out and capture those. The interesting thing about the asteroids is that that kind of research can combine efforts to avoid asteroid collision with Earth. At the same time, we're mining them to get the resources for Earth.
The asteroids are a goal for space resources for two reasons. One, in terms of the energy and rocket propellant required to get there and back, they're the most accessible targets beyond low Earth orbit for humanity. Two, they have many valuable materials that can be used in space. The first valuable material that we'll harvest from asteroids are the ingredients in rocket propellant. If we can turn the asteroids into refueling stations in space, we can dramatically drop the cost of human exploration.
The main asteroid belt between the orbits of Mars and Jupiter and the so-called Jupiter Trojans, which are co-orbital with Jupiter, are the places where most of the known asteroids are located. In addition to those asteroids, there are other orbital families of asteroids with important populations, such as the near-Earth asteroids, which have orbits close to Earth. Up to date, several missions have been sent to visit some of these near-Earth asteroids. The first one to be visited by a spacecraft was asteroid 433 Eros, when NASA's Near-Earth Asteroid Rendezvous probe landed on its surface in February 2002. A second near-Earth asteroid, 25143 Itokawa, was visited in 2005 by the Hayabusa mission of the Japan Aerospace Exploration Agency, JAXA.
So the Hayabusa mission, which was performed by JAXA, went out to the asteroid Itokawa, and they actually took a very small sample from the surface of that asteroid. It was a little less than 1 milligram of material.
The fact that asteroids are small rocks floating in space offers several advantages, but also some disadvantages. One of the greatest advantages is their low gravity because of their small size, which means an important reduction in the costs and risks of landing in comparison to the Moon's or Mars's higher gravities. This fact also makes the construction of structures much easier. The fact that there are over 300,000 asteroids identified to date is another pro, as there would be a large number of possible sites.
There are asteroids everywhere in the solar system. I mean, literally everywhere. Not every single location, but there are asteroids here and there.
It's known that there are carbon-rich, metallic, and stony asteroids. This variety in their chemical composition makes them potentially useful as materials for building or fueling spacecrafts. Material mined from asteroids could be a basis for trade economy, and precious metals may even be returned to Earth or other colonized worlds from asteroid mines for economic gain.
And with public-private partnership, we can build the infrastructure that moves industry in space, not in 20 or 50 or 100 years, but starting in 3 or 4 or 5 years. And we can be harvesting rocket propellant in less than 10 years and building the transcontinental railroad to the solar system.
Many asteroids contain large amounts of water and other volatiles, as well as carbon, all of which are necessary for life support.
The ones that we're going to be interested in first are what we call carbonaceous chondritic types. And the magic constituent that they have that we're going to be after is water.
These resources could also be transported to other places in the solar system where they are scarce, and at a much lower cost than launching such materials from larger bodies such as the Moon or Mars.
We get better space propulsion utilizing the asteroid volatile material, the water and carbon dioxide, which we can convert into rocket fuel. We'll have more mobility in space, and as that happens, we'll go further and further into the solar system. And that's the first small industrial scale mission to bring back an economically important quantity of rocket propellant that can change the economics of space.
However, to make this future mining industry a reality, we should solve several challenges, such as the asteroid's low gravity and zero atmosphere, which make them vulnerable to cosmic radiation and to the impact of small objects. There are several private companies interested in mining asteroids. On 2012, the private company Planetary Resources announced a plan to harvest resources from asteroids. The plan has a few opponents who doubt the profitability of the operation, as the cost of extracting resources like precious metals, no matter how abundant they are in the asteroids, would be much higher than its extraction cost on Earth.
There are some materials that potentially could be of use on Earth. Platinum group metals is usually mentioned. It, however, is very difficult, at least now, for asteroid mines to compete with Earth mines.
Nevertheless, Planetary Resources thinks that the plan will be profitable if they are able to develop technologies that reduce the costs of spaceflight. One way to reduce those costs would be the creation of space facilities such as propellant production plants. The asteroid mining company TransAstra is betting strongly on a plan to produce propellant using the water contained in asteroids. Molecules of water would be split into their atoms of hydrogen using solar energy.
TransAstra has a business plan that's focused on extracting rocket propellant from asteroids. You could call that asteroid mining if you want. And then using that rocket propellant to fill refueling stations in space, to refuel NASA spacecraft and private sector spacecraft.
Another very promising asteroid mining company is Deep Space Industries, founded in 2013.
So Deep Space Industries is an asteroid mining company. We expect to be mining asteroids in somewhere in the next 6 to 10 years.
Its goal is to provide the technical resources, capabilities, and system integration required to prospect for harvest, process, manufacture, and market in-space resources.
So when we look at which asteroids that we want to mine, we're looking at several different things. We want to know that they have the materials in them that we can extract and that they're relatively easily extractable. But one of the biggest things is accessibility. They have to be relatively close to the Earth.
Nowadays, there are several projects led by public institutions and private companies, such as SpaceX, Blue Origin, or these asteroid mining companies that show that future expansion of human beings beyond the limits of our planet is not so far in the future.
We stand at a very important time in history. There have been a few important changes that have occurred in the last few years. One, for the first time we know that there's valuable water and other materials in the lunar poles and in the highly accessible asteroids that can be used to make very cost-effective rocket propellant to make it much less expensive to do deep space exploration. Two, we now have the technology to build fully reusable, very affordable spaceships. Elon Musk and Jeff Bezos are leading the way in that way. They're starting off with fully reusable rockets that launch into space. It's very obvious that the next step is fully reusable spaceships that stay in space and fly the space line. But those fully reusable spaceships in space will require rocket propellant, and we'll get that from the lunar poles and the asteroids.
We might be on the verge of witnessing a new whole revolution that will change the world as we know it now. The space colonization race has just begun.